Hello everyone, this is Dr. K. Jagannayaki, Professor in MBA Department, Institute of Aeronautical Engineering, Hyderabad. Today I would like to discuss with you about Quants and Cost. So after going through this topic, the learner will be able to understand the concepts of Quants and Cost, the definition of Quant, the applications and assumptions of Quants, Quant maps, how to read them, and what are the properties of Quants, and finally I would like to go with a brief introduction about Cost. So let us start with Quants. An Quant in economics, it is a curve that when plotted on a graph, it shows all the combination of two factors to produce a given output. So here we are talking about two factors. One is the capital, another one is labor. So this kind of Quants used in manufacturing sector with capital and labor as the two factors, and Quants can show the optimal combination of inputs that will produce the maximum output at minimum cost. An Quant curve is a concave shaped line on the graph. So if you observe, we always used to get this kind of curve. So this is known as concave shaped line on a graph, which is used to study the microeconomics, that all charts are the factors or inputs that produce a specified level of output. So this graph is used as a metric that influence the inputs. So most commonly we are going to discuss about capital and labor. They have an obtainable level of output or production. So the Quant curve assists companies and businesses in making adjustments to inputs to maximize production and thus profits. So understanding an Quant curve, the term Quant broken into two Latin words, iso and quant. Iso means equal quantity and iso means equal and quant means quantity. So the curve represents a consistent amount of output. The Quant is known as an equal product curve or a production indifference curve. It may be also called as iso product curve. So most typically, an Quant shows the combination of capital and labor and the technological trade-off between the two, how much capital would be required to replace a unit of labor at a certain production point to generate same output. So even though you are making changes in the input factors, the output remains constant. So that is the concept of Quant. So labor is often placed along with x-axis of the Quant graph and the capital along the y-axis. Definition of Quant. Quant shows all combination of two factors that produce a given output. If you see the diagram, the Quant shows all the combination of labor and capital that can produce a total output of 4000. So we are using different combinations, 10 units of capital and 35 units of labor. As a result, you are going to produce 4000 units. If you increase the capital and decrease the labor, again you are going to produce the same number of units. So in the above Quant, this could be 20 capital and 18 labor, or more capital intensive, or 9 capital and 35 labor, which is more labor intensive. So both used to produce the same level of output, that is 4000 units. An Quant is usually shaped convex to the origin because of the law of marginal rate of technical substitution, which means that there are diminishing returns from using more of one factor of production. Either you are going to increase the capital and you are decreasing the labor, or vice versa. So it always follows law of diminishing value of returns. Then what are the assumptions and applications of ISOQuant? Coming to the applications, it helps firms to adjust their input against their output. So they used to have different types of combinations. So basing on that, they can able to achieve their desired level of output. To measure the influence of inputs on production levels and output possibilities, and also it an important component of for analyzing producer behavior. It illustrates all the possible combinations of two factors that can be used at given quantities and for a given producer's budget. So based on the budget, we can able to produce the goods to the consumers. Then coming to the assumptions. So out of 4 input factors, we used to consider only 2 factors. One is capital, another one is labor. And factors of production are divisible into small units and used in various proportions. So we can divide easily and we can use different combinations. 1:2, 2:5. So whatever way you want, you can adjust them and we can use in various proportions so that we can reach the desired level of output. And third one is technical conditions of production are not possible to change at any point of time. So you cannot change the technical conditions. So whatever technology or machinery you are going to use, the same we have to use. Only you can make changes in the 2 factors. Either you can change the capital or you can change the labor, but all other factors remains the same. Different factors of production are used in a most efficient way. Then what is marginal rate of factor or technical substitution? The marginal rate of technical substitution shows the rate at which you can substitute one input such as labor for another input such as capital without changing the level of resulting output. So if your expectation output is 100 units you have to produce, and in order to achieve that 100 units, we can use different combinations of labor, 10 units of labor and 20 units of capital, or you may increase 20 units of labor, 40 units, but whatever proportion you are going to take, that should not affect the overall output. So technically, we can substitute labor with capital, capital with labor, but in the real sense, in the practical way, it may not be possible. So the ISOQuant or the curve on a graph, it shows all the various combinations of 2 inputs that result in the same amount of output. So the formula for MRTS is MRTS of L, K. L stands for labor and K denotes the capital. So the change in capital divided by the change in labor. So whereas MPL and MPK, they denotes marginal product of labor and marginal product of capital. For example, when marginal rate of substitution is the amount of one factor that can be replaced by another factor. For example, in this case, if you take 2 units of capital could be replaced with 1 unit of labor. So as a result, your MRS would be 2 units. The same here I have explained with the help of a graph. If you see the combinations of input A, B, C, D, E and units of capital, we have taken 1, 2, 3, 4, 5 and labor. If the capital is 1, the labor is 12. If capital 2, labor 8, capital 3, labor 5. So like that we have taken different combinations and based on that we have calculated MRTS. So for different combinations, when B, if you observe the combination of B, the units of capital 2, 8, your MRTS is 4. So like this everywhere we have calculated the marginal rate of technical substitution. What is the significance of MRTS, marginal rate of technical substitutes? It displays the rate at which the other can substitute it for a given input, either labor or capital, thus retaining the same output level. So a decrease in MRTS along an isoquant is called declining marginal rate of substitution for generating the same level of output. The producer equilibrium is that the least amount of cost to achieve the maximum amount of profit will known from MRTS. So it must be noted that only two factors of production are present in a plant, that is factor A and factor B. The factor A can produce a higher quantity of output than factor B. Then diminishing marginal rate of substitution, if the firm employs 2 labor and 40 capital, then employing an extra worker can enable it to save 10 capital, and this is quite an efficient saving. The firm only has to pay one extra worker, but it can save the cost of 40. However, at a combination of 9 labor, employing an extra worker enabling a saving of only 2 capital. So that is the reason the firms always they used to go with different kinds of combinations so that the total cost should be minimum. Therefore, the more that workers are employed, there is diminishing rate at which you can substitute the other factor. There comes a point where employing more workers barely saves any capital at all. So this is when diminishing returns of labor is very high and workers effectively get into the other's way. So just you are going to substitute as your labor cost will increasing and your capital is also increasing. So in that case, we have to go for this marginal rate of technical substitution. As one moves down the isoquant, output remains the same. Therefore, the output gained from employing more labor must equal to the output lost from employing more capital. So MPP of L and percentage change in labor is equal to MPP of K into percentage change in K. So this equation gives us marginal rate of substitution. Then comes isoquant map. An isoquant map shows different levels of output. For example, level 1 show that the combinations of capital and labor that can produce 4000 total production, and L2 level 2 shows that the combination of capital and labor that can produce 5000 total production, and L5 is a higher output than L4. In the short term, a firm faces a trade-off along one particular isoquants, but in the long run, a firm can invest in increasing capital stock and produce at a higher output for the same quantity of labor. So the firm may not change the labor, but it is going to make changes in the capital. As a result, they can produce more output and more productivity. Then coming to the properties of an isoquant curve, the first property is that an isoquant curve slopes downward and is negatively sloped. So if you observe the isoquant curve, it always go like this, slopes downwards. So this means that the same level of production only occurs when increasing units of input are offset with lesser units of another input factor. So this property falls in line with the principle of the MRTS. As an example, the same level of output could be achieved by a company when capital input increases but labor input decreases. The second property, an isoquant curve, because of the MRTS effect, is convex to the origin. So this indicates that factors of production may be substituted with one another. So if you see, it is concave towards the origin, right? convex to the horizon, whereas it is concave. So when you go away from the horizon, so it happens because of the changes in terms of labor and capital. So this indicates that factors of production may be substituted with one another. The increase in one factor, however, must still be used in conjunction with the decrease of another input factor. So if you are going to maximize the capital, then you are going to minimize the labor. And if you are minimizing the capital, and you have to maximize the labor. The third property is isocurrent curves cannot be tangent or intersect one another. So in previous case, we have seen that a graph with a different levels of production. So whatever the proportionate change in terms of various levels, L1, L2, L3 and so on, they never intersect and touch each other. The curves that intersect are incorrect and produce results that are invalid as a common factor combination on each of these curves will reveal the same level of output, which is not possible. And fourth property is that isocurrent curves in the upper portions of the chart yield higher outputs, and this is because at a higher curve, factors of production are more heavily employed. Either more capital or more labor input factors result in a greater level of production. And fifth property is that an isocurrent curve should not touch the x or y axis on the graph. So if you observe, they never touch x and y axis. If it does, the rate of technical substitution is wired, as it will indicate that one factor is responsible for producing the given level of output without the involvement of any other input factors. And sixth property, isoquants do not have to be parallel to one another. So the rate of technical substitution between factors may have variations. And isoquants curves are oval shaped. This allows firms to determine the most efficient factors of production. So as a result, they are always oval shaped. Then how to calculate an isoquant? An isoquant is a graph showing combination of two factors, the capital and labor, that will yield the same output. To calculate an isoquant, we use the formula for marginal rate of technical substitution. MRTS of labor, capital is equal to minus of the percentage change in capital divided by percentage change in labor, which is equal to marginal product of labor divided by marginal product of capital. In the graph of an isoquant, where capital represented with K on its y-axis and labor on x-axis, the slope of isoquant or the MRTS at any one point is calculated as dl by dk. Then comes isocost. Isocost refers to that cost curve that represent the combination of inputs that will cost the producer the same amount of money. In other words, each isocost denotes a particular level of total cost for a given level of production. If the given level of production changes, the total cost changes. Thus, isocost curve moves upwards and vice versa. Isocost shows all the combinations of factors that cost the same to employ. So in this example, if you see a unit of labor and capital, it costs 6,666 pounds each. If we employ 30 capital and 30 labor, the total cost will be 400,000 pounds. If we employ 10k and 50l, the total cost will be $4,000. So whatever may be the combination, the total cost should remain the same. So that is known as isocost. Mathematically, an isocost line can be expressed as C is equal to WL plus RK, where C is known as cost of production, W represent price of labor or wages, L denotes unit of labor, and R represents price of capital or interest rate, and K stands for units of labor. Then change in labor cost. So if you see this graph, initially the cost of labor and capital both is 5,000 pounds because we have taken 60 labor and 60 capital. So if you multiply 60 labor, 60 into 5,000, you get 300,000 pounds. However, if labor cost rises to 10,000, then the ISO cost shift to the left. Now, to keep the cost of 300,000, a firm could only employ 30 workers. The slope of ISO cost is therefore PL by PK. So the same thing we have projected in this graph, whatever data we have taken to represent ISO cost and ISO cons. The methods, we have taken different types of methods, units of capital and units of labor. We have taken different proportionates. Basing on that, we used to have different types of curves, as well as the cost line also may vary from one proportionate value combination to another one. Then profit maximization. To maximize profits, a firm will wish to produce at the point of the highest possible ISO quant and minimum possible ISO cost. So in this example, we have one ISO cost and three ISO quants. So this line represents the cost curve, ISO cost, and these three, they denotes ISO quant. So with the ISO cost of 400,000 pounds, the maximum output a firm can manage would be a TPP of 4,000. If it is produced at say 13K and 48 labor, it would only be able to produce a TPP of 3,500. So a total TPP of 4,500 is currently not possible without increasing cost beyond 400,000 pounds. Then least cost method of production. The problem of least cost combination of factors, it refers to a firm getting the largest volume of output from a given cost outlay on factors when they are combined in an optimum manner. So in the theory of production, a producer will be in equilibrium when given the cost price function, he maximizes his profits on the basis of the least cost combination of factor. So for this, he will choose the combination of factors which maximizes his cost of production, and this will be the optimum combination for him. And another way of seeking to maximize profits is to target an output, say 400, and then the ISO cost with lower or lowest possible cost. In this case, the ISO cost which touches the tangential point of TPP is a TC of 400,000 pounds. So this is a point where both becomes equal, and this point is tangential point where the manufacturer can go with the least cost combination. Then what is the least cost decision rule? The least cost combination of two inputs. So basically from the beginning onwards we are talking about only two factors, that is labor and capital, to produce a certain output level. So it occurs where the ISO cost line is tangent to the ISO quant. So in this case, this is the tangent point. The lowest possible cost for producing that level of output represented that ISO quants. So at that particular level, 2 units of input X and 20 units of input Y. So that is the combination where the total cost should be minimum and at the same time you can maximize your output. So this tangency point implies the slope of the isoquants is equal to the slope of the isocost curve, that combination of input. So it is the intersecting point of both isocost and isoquant. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.